2023 has come and gone, and we had another year of amazing geospatial innovations. And that's what this video is about today. We're going to talk about the highlights of different geospatial technologies that either grew, expanded, or just started within this past year. And I think there's a lot that there is to talk about, so let's jump right in. GeoParquet is the first technology that I'm going to talk about. And while GeoParquet did not start in 2023, this was the first year it hit a 1.0 release, and we really started to see some wider adoption of this new file format. Now, if you aren't familiar with GeoParquet, there's a blog post here and some other links that I'll share in the description below that literally talk about it in greater detail. But the most important thing that you need to remember is that it is a much more compressed file format that allows you to have a smaller storage footprint as well as faster reads in different tools. And that makes it really compelling to, well, first of all, have smaller file sizes, but also actually do what you want to do a lot faster. And we've also seen more open data sources actually support this format, such as the Overture Maps Foundation, that actually share these really big data sets in GeoParquet to make them, well, a lot easier to access and download, and then ultimately use as well. Now for me, I've actually completely pretty much switched over to moving any file format that I have into GeoParquet this past year. So I've been really on board and started using a lot, and the performance benefits, well, have been quite amazing, I do have to say. If you need more proof, take a look at this chart here. This kind of explains to you a little bit more about the performance, but I think these charts speak for itself. My bold prediction for 2024 is that we start to see GeoParquet become one of the top formats with geospatial data like GeoJSON or shapefile or anything like that. So we'll see if I'm right next year, but that's my bold prediction. The other thing that took me really by surprise this past year was actually DuckDB. Now, I first learned about DuckDB at a conference in the spring in Austin at Data Council, and I saw the founder of MotherDuck actually talk a little bit about their sort of strategy behind this, and then I actually started playing around with it and using it. Then a few months after that, the spatial extension actually became part of the core system when you download it, so you don't have to extend and use something else. It's just right there, easy for you to use. And after that, I actually started to see this grow in a lot of places. Here's some different talks and videos and blog posts that have actually started using this. So it's actually taken the spatial community by storm, primarily because it's so easy to use. You can use it in Python and start creating a database there, or just reading files like Parquet or CSV, even GeoParquet. And it's actually super easy to use in a command line as well. And the best part is that it's really, really efficient. It's a super small footprint. There aren't any dependencies, and you can just start writing SQL queries on top of your files right from the beginning. It's just really easy to use, and the amount of data that can actually process is really impressive. I have a video about this over here if you want to check these out. They're definitely talk a little bit more about that, but my bold prediction is that we start to see this a lot more in the coming months, and I actually think you start to see DuckDB as a core geospatial database more and more, especially for large data. One cool note about DuckDB, I talked about this in my talk at PostGIS Day, is that it actually connects, and there's a foreign data wrapper into PostGIS. So if you already use PostGIS, you can actually connect a separate DuckDB data store to read really large files and then join that to your data for more complex spatial operations in PostGIS. So it's kind of like this almost data warehouse type extension that lives on your computer and allows you to process really big data. So definitely check that out. I think this will grow in the coming year as well. Cloud native file formats actually took off a lot this year as well. In addition to their funny names like Cog, Stack, Czar, and others, they also actually started to grow. I noticed that more and more companies are using the Spatiotemporal Asset Catalog, or Stack, to share raster data. They're actually pushing and publishing data in the cloud-optimized GeoTIFF format. PostGIS allows you to read external TIFF files in the cloud-optimized GeoTIFF format. So more and more tools are starting to use these, and it really just makes downloading raster data or using it so much easier, especially on like a global scale or with like really small resolution. Just because you don't have to download everything all at once, you can just grab the bits and pieces that you need and go from there. There's a few other tools that actually use this. We actually use cloud-optimized GeoTIFFs as our raster import file type to our importer into BigQuery at Carto. So more and more tools, more and more open data repositories are starting to use this. So I definitely start to look at this to continue over the course of next year. My really bold prediction is that these file formats start to become some of the primary ways raster data is distributed online. We're already kind of seeing that, so this is a little bit of a cheat, but I think you will start seeing this grow more and more, especially with the cloud providers when they provide different raster data sets. So the next one is from probably, I think, one of the most productive people in geospatial, Dr. Qisheng Wu from the University of Tennessee. If you haven't used his packages like Gmap or the one I want to talk about today, Leafmap, you need to be doing that, because Leafmap is probably the most comprehensive Python toolkit in any geospatial thing that you might ever do. It pretty much has every package you need summed up into one place using a single sort of API and function calls to actually run different processes. That goes for raster data, vector data, actually creating and visualizing data, like literally everything in between. And when something new comes out, it shows up in there right away. Like DuckDB, it's already in Leafmap, and Longboard, which is a really cool visualization toolkit in Python, it's already in Leafmap. Like I said, I kind of give this my blessing as the single greatest toolkit in Python for geospatial. So it's definitely something you can check out. And there's literally almost 100 tutorials that you can actually pull from and start using. So there's really no excuse for you to start using that. And I think given his production and everything he's done for geospatial, we could put Dr. Qixing Wu as one of the greatest of all time in GIS and geospatial. And this is another package from Professor Wu that I want to talk about that kind of hits on some of the generative AI stuff, and actually the model for Segment Anything. If you actually know a little bit about Segment Anything, it's an imagery model that can look at an image and kind of detect things with text inputs. If you want to type in dog, you can find an image of dog. If you want to type in the word books and kind of try and find books in the picture, it'll do that. What Professor Wu did is actually take that and apply it to satellite imagery. So if you want to find maybe bodies of water or cars, I've tried it out with things like cranberry marshes, and it works pretty well depending on the granularity of your imagery. So it's really good for this quick analysis and even working through some different data sets. If you're building something in production and looking at something specific, you still want to probably build your own model, but man, does this make things so much easier to really work through imagery. And especially if you're not skilled with this, like this is not my specialty, it's really easy to just grab an image, do one thing, and then move on with your day. And then the last thing I want to talk about is the improvements to the geospatial cloud ecosystem that happened this past year. So each of these different cloud providers made some major enhancements and improvements in their cloud offerings for geospatial specifically. BigQuery added connectivity into their Google Earth Engine system, so you can now kind of connect the data warehouse and Google Earth together, which is really cool. Snowflake added support for the geography data type. So now it's one of the few data warehouses where you can actually perform different projected calculations and actually use that instead of just the geometry or the 4326 projection that you might want to use. They also added their Snowpark container services, which is basically like using their really powerful infrastructure to run Python containers and do analysis with those, which is really great because if you have something in Python and you want to connect it to data in Snowflake and add that sort of powerful scalable data warehouse element to it, this is an easy way to do that. AWS did some great things too. They added geospatial support in SageMaker, which is their AI machine learning toolkit that allows you to have some predefined models to run imagery through, as well as models you can build on your own. In addition to that, they are also now supporting the H3 spatial indexing system, and that's another amazing improvement as well. So excited to see all of those things happening in the cloud. And finally, I know many of you use Apache Sedona for scaling geospatial processes in Spark. Whereabouts is a startup that actually has a lot of the people that contribute and start and work on Apache Sedona, and then they've created it as its own cloud product. So that removes some of that difficulty in terms of creating a Spark cluster or doing some of that kind of complex computing stuff. You can just start using their service now and running notebooks in Sedona, which I think is another great addition to this sort of cloud spatial ecosystem. I don't have a great prediction for cloud computing and geospatial in 2024 quite yet. I think you'll start to see a combination of things like using artificial intelligence and some of that AI things within geospatial and in the cloud, but probably the cloud more broadly. But honestly, I see more people starting to adapt the cloud. I see more organizations using it maybe for file storage or maybe for databases and data warehouses. So that's probably the trend I would watch out for, is actually more and more organizations actually moving parts of workloads into the cloud, and that's starting to really ramp up over there. So that's it. That's everything I have for 2023. It was a great year. I'll see you guys this time next year. Yeah, I really couldn't make it through this video without mentioning AI, but I'm actually gonna put that in another video talking about what I think is going to happen in 2024. So you can find that video somewhere here. I never know where to point, but it's on this page. Click it and check it out, and you can see my predictions for 2024, which includes things like what's going to happen with AI and geospatial. So check it out, and I'll see you over there.